Hi there, I'm Monged, and this is a brief walkthrough of an end-to-end project I have developed only using Microsoft Fabric. So imagine we approached by a client asking for help, and they said, "We are an ambitious company, we have data, and we want to make use of it to help us make data-driven decisions. So we need to build the infrastructure that will help us with that and develop analytical solutions like dashboards, and potentially even machine learning or AI capabilities to support our ongoing goals." And to meet these requirements, we need a platform that offers both flexibility and scalability to host our data. Additionally, the platform must support automation and workloads. Also, it should provide data processing capabilities and a collaborative environment for different data teams like data engineers, analysts, or scientists. And finally, we need a unified platform that is fully compatible and integrated. So in this walkthrough, I will demonstrate how we can fulfill these requirements using only Microsoft Fabric to deliver an end-to-end architecture or solution that is scalable and comprehensive. The entire design will be automated and orchestrated using pipelines, notebooks, and stored procedures, ensuring the solution keeps running without manual interaction. Of course, we will follow best practices by parameterizing the entire design as much as possible. Additionally, we will be applying incremental loading, ensure proper error handling, and implement logging for runs and actions. Our data will come from three primary sources: an application or website data accessed using API, an on-premises database such as OLTP system, and a data lake for unstructured or semi-structured data. And here we will adopt the Medallion architecture for this project. But why this approach? Why introduce data redundancy? Shouldn't we aim to leverage the one lake concept within Microsoft Fabric? The choice of Medallion architecture depends on the project and organization size. In our case, we are designing for an enterprise which has multiple departments, sectors, and domains, making it essential to use a structure that provides scalability and effective data management. So we will implement three layers: the bronze layer, which contains raw data with no transformation applied; the silver layer that will host cleaned and formatted data; and the gold layer where we will apply business logic and transformation tailored to different departments. In the bronze and silver layers, we will use the lake houses as a storage place, which offers the flexibility and scalability we need. But in the gold layer, we will be using warehouses, which will enable us to leverage T-SQL capabilities for better data management, performance, and security, like using row level security, column level security, data masking, and other SQL features. So we have three data sources. The first source is data from a website or application, which we will be accessing using API. The second source comes from an on-premises OLTP database. And the third source is from a cloud storage provider, which is basically a data lake. To simulate this, we will be using Dropbox, which is a cloud-based file storage where you can store various types of files like videos, CSVs, and more data documents. So some of our data will be hosted there, and after this, we'll be utilizing Dropbox API to ingest our data. And if we go to Dropbox API documentation, we can find the necessary guidance for establishing a connection and interacting with the Dropbox API. This includes performing various actions such as sending requests to the API. For example, we can use the list and download endpoints to view our files on Dropbox and download specific files after establishing a connection by creating an app and using access tokens. Going back to Fabric, we'll be using pipelines to accomplish this by using various activities that will list all files there and start sending requests to Dropbox to retrieve the content of each file. And after this, we'll be using copy activity to save the content in our bronze lakehouse in its raw format and appropriate structure. The second source is on-premises OLTP database, and its data will be migrated to cloud. And to simulate this, we will be using SQL Server as our database. And to be able to migrate, we will need to establish a connection between our database and cloud platform. And to achieve this, we will configure a gateway to facilitate the migration process by using the on-premises data gateway provided by Microsoft. We will incrementally load our data by creating a watermark table with a threshold value. This threshold will be used to filter the data, ensuring only newly added records are included. Once we retrieve the watermark value, we will iterate through each table and use a copy activity to fetch the data, then load it into our Bronze Lakehouse. And the last source we have is a data lake that is hosting some of our data that we need to retrieve. So first we will use a lookup activity to retrieve all files there. Then for each file we will use a switch activity to determine its type. After this we will use the appropriate copy activity to load the data into our Bronze Lakehouse. And if we go to our Bronze Lakehouse, we will find that it is divided into 3 directories, each corresponding to a different source. Additionally, each directory is organized into subdirectories by year, month, and day, followed by file type. We also have our watermark table, which is used for incremental loading, and it is updated after each run. After completing the bronze layer, we move on to the silver layer, where we transform and process the data into a cleaner and more structured format. To achieve this, we will use notebooks. While data flows are an option, notebooks are better for parameterization, customization, and complex processing tasks. The Silver Notebook pipeline is designed to manage this process. It retrieves all notebook names and runs them in parallel. Each notebook processes the data and creates a corresponding table in the Silver layer, which is stored in a separate lakehouse for better organization and accessibility. Notebooks in Microsoft Fabric are similar to those in Databricks, leveraging Spark capabilities for efficient data processing. Here we use PySpark to define a schema, load our data, and implement incremental loading using watermark techniques. After processing our data, we log each run with success or failure, and finally we append the newly added records to the Silver data table stored in our Silver Lakehouse. After completing the Silver layer, we would proceed to the Gold layer, where we apply business logic and store our clean data in a structured format. Since our company has different departments or sectors, we will utilize warehouses to host and preserve our data. This approach ensures separation, enhances security, and better management. In each warehouse, we will select and create tables from the tables in our Silver layer. After this, we will create a stored procedure to process the data and insert only newly added records. Additionally, we will ensure proper error handling and logging after each run. After creating the stored procedures for our table, we will automate and parameterize the execution by using a pipeline. First, we will retrieve all stored procedures using a lookup activity. Then, we'll iterate through each one and start executing and logging them. Once the gold layer is created and updated, our data is prepared and ready to be utilized for analytical usage. For example, we can develop semantic models and dashboards to derive insights from our data, enabling us to make data-driven decisions, monitor performance, identify trends, improve forecasting, and enhance operational efficiency. To orchestrate the entire process, we will use a master pipeline responsible for running each pipeline sequentially. It will begin by executing the Universal Harvester pipeline to create the bronze layer. Next, it will run the Silver Notebook pipeline to process and transform its data into our Silver Lakehouse, followed by the Gold pipeline that runs our stored procedures to finalize the architecture. Finally, the master pipeline will refresh the semantic model to ensure it reflects the latest updates on our dashboard.